Now we're going to take a look at another sampling distribution. This time we are looking at the distribution of p hat, the sample proportion. So the mean of the sample proportion is equal to the population proportion p. And the standard deviation here is depending on the sample size, once again, in the denominator, which means the larger the sample size you have, the smaller the standard deviation of the sampling distribution. And note that the shape of the sampling distribution is normal, which means we can use functions like normal CDF and inverse normal in our calculator to find values associated with a sampling distribution of p hat. So let's try an example. According to creditcard.com, 29% of adults do not own a credit card. Suppose a random sample of 500 adults is asked, do you own a credit card? Describe the sampling distribution of p hat, the proportion of adults who do not own a credit card. Okay, so anytime we're asked to describe a sampling distribution, we're being asked to find two things: the mean and standard deviation of the sampling distribution. So the mean is equal to the population proportion, which here was given as a percentage. You want to write it as a decimal, and we will only be using it in decimal form in this section. The standard deviation has to be computed, so it is the square root of p times 1 minus p over the sample size. So let's put this in the calculator. Square root of 0.29 times 1 minus 0.29 divided by 500. So I'm getting approximately 0.02. So I'll use these now for the next few questions. What is the probability that in a random sample of 500 adults, more than 30% do not own a credit card? So it says more than. So this is the probability that p hat is greater than, and instead of 30%, I'm going to write 0.3. So this time our random variable is p hat. We just do a normal CDF using the mean and standard deviation that we found above. So this will be normal CDF. The lower bound was given, 0.3. Upper bound is 1E99. The mean is 0.29. And the standard deviation we found above was 0.02. So we can put this in the calculator. Second, vars, number 2, normal CDF, 0.3, comma, 1E99, comma, 0.29, comma, 0.02. We get about 0.3085. Part C, what is the probability that in a random sample of 500 adults, between 25% and 30% do not own a credit card? Okay, so in this example, we were given lower and upper bounds. So it's the probability that p hat is between these two values. Once again, I am expressing them as decimals, as you will need to do for this entire section. So it's still a normal CDF. The parameters of this normal CDF haven't changed, but the bounds have. The mean is still 0.29, and the standard deviation is still 0.02. Let's put this in a calculator. Lower bound 0.25, upper bound 0.3, mean 0.29, standard deviation 0.02. Okay, and I'm getting about 0.6687. Would it be unusual for a random sample of 500 adults to result in 125 or fewer who do not own a credit card? Why? The important thing to note here is that you need to convert this into a proportion. So it's 125 out of 500. 25 divided by 500, which is 0.25. Okay, you cannot use the number 125 directly, because remember our random variable is p hat, the sample proportion. So that value, 125, needs to be converted to a proportion. And it said fewer, so it's the probability that p hat is less than 0.25. So it's still a normal CDF. Oops. This time our lower bound is negative 1E99. Our upper bound is 0.25. And the mean and standard deviation are still the same as above because we're still referring to a sample of size 500. So we type in the calculator, and we get approximately 0.0228. We were asked if it would be unusual. We found the probability. 0.0228 is less than 0.05. So, yes, it would be unusual. Okay, and the answer is that question. Let's look at one more example for 8.2. 80% of American children believe that Santa Claus is real. Suppose you take a simple random sample of 200 random American children. Describe the sampling distribution of the sample proportion. Okay, so once again, we will give two values here. We will give the mean of the sample proportions and the standard deviation of the sample proportions. The mean of the sample proportions is equal to the population proportion, which is given here as a percent. Convert it to a decimal. And then the standard deviation we'll have to compute using the formula. It is the population proportion, P times 1 minus P, divided by the sample size. So let's put it in the calculator. Square root of 0.8 times 1 minus 0.8 divided by 200. So we're getting about 0.028. Now we can use these to answer the next two questions. What is the probability that fewer than 150 of the children say they believe in Santa? Okay, so don't forget that the random variable is p hat, which is a proportion. So this needs to be converted into a proportion, 150 over 200. It's 0.75. Okay, and it says fewer, so we're looking at the probability that p hat is less than 0.75. So we will use a normal CDF. The lower bound would be negative 1e99, the upper bound 0.75, and the mean and standard deviation we found in part A. Okay, so put this in the calculator. Lower bound negative 1e99, upper bound 0.75, mean 0.8, standard deviation 0.028. Okay, so I'm getting approximately 0.0371. Part C, what is the probability that between 160 and 175 of the children believe in Santa? Okay, so keep in mind that these both need to be converted to proportions before we can use the calculator. Sample size is still 200. So it's really asking us the probability that p hat is between 0.8 and 175 over 200, 0.875. So this is the probability that p hat is between 0.8 and 0.875. So we're doing a normal CDF with the same parameters. We are just changing the bounds. The mean was 0.8, the standard deviation was 0.028. Okay, normal CDF, lower bound 0.8, upper bound 0.875, mean 0.8, standard deviation 0.028. So we're getting about 0.028.